Hello class, and welcome to your Exam 1 video solution guide. So I'm going to go through this and show you the solutions one by one, okay? So the first problem, I just asked you some skills that you improved in the last 6 weeks. I really enjoyed reading your answers, and I learned a lot about what of the class has been useful to you so far. I'm going to use that information to try to influence the rest of the semester. So thank you for answering that so well. For problem 2, I'm going to just get started. And the idea behind this video is I'm just going to walk through all of the problems on the exam and let you get some idea of how you did, okay? So in this problem, you have a 7.5% tax rate applied on the price of a shirt. The final cost of the shirt, which includes the cost and the taxes, is $38.24. So what was the price of the shirt before the tax was applied? To solve this, I let C be the cost of the shirt before tax. And so if I take 0.075 times the cost of the shirt, and then before taxes, and then add that to the cost of the shirt, that should give me my final price, $38.24. So this should be 1.075C is equal to 38.24. If you divide both sides by 1.075, so you do 38 in your calculator, 0.24, divided by 1.075, you get that the cost of the shirt is about $35.57. So for this one, we did some problems like it in homework. If the setting up this equation, if that seems painful, if you're like, oh, Sarah, why? For this setup, definitely talk to me in office hours, talk to me about it before or after class, and I'll see if I can help shed some light onto why I made those choices and what that's about, okay? For problem 3, it's a Venn diagram problem. It's similar to some of the set theory stuff we did in class. It says 100 students are surveyed, 60 take English, 40 take math, 50 take chemistry, 30 take English and math, 35 take English and chemistry, and 25 take all 3 courses. Construct a Venn diagram that organizes the information. How many students are taking at least 2 subjects, and to shade the area of the Venn diagram that gives you this information. So right off the bat, it's a circle problem, right? We should have some Venn diagram. So I'm going to draw 3 circles here for my Venn diagram and then label them. So we're going to have this one being math. We'll have this one be chem. And we'll have this over here be English. So most of us nailed the first thing, which is that if 25 students take all 3 courses, that's this spot here in the center. We're going to fill that in with a 25. So now let's work backwards from that. We know 25 students take all 3 courses. And we know 35 students take English and chemistry. So if I look at the part of the Venn diagram that talks about English and chemistry, that's here, right? So there's already 25 people that I've written down because they're taking all 3 classes, English, math, and chemistry. So to hit that 35 number, 35 people are taking English and chemistry. That means there have to be 10 people here who are just taking English and chemistry, but they're not taking math, right? So there's 10 people who are taking just English and chemistry, 25 people who are taking English and math and chemistry, and that gives us the total of 35 that take English and chemistry. Again, working backwards, I see here that 30 people are taking English and math. So if I look at the part of my Venn diagram that's English and math, that's this region here. So again, there's 25 people who are taking all 3 and 30 people who are taking English and math. And that lets me know that I'm filling that in with 5. And one nice thing about this YouTube video is if you're like, wait, Sarah, say that again. you can rewind and listen to it again. Yeah, you can go slow, you can go fast, you could skip this problem. If you know that you did it right, you could use this video however you want, however it's going to be most useful to you. So now we have our 30 who take English and math, our 35 who take English and chemistry, and our 25 who take all three. So what we're going to look at is our final totals, right? So I know that 50 people total are taking chemistry. So 50 for chem, I'm going to say equals C, right? And that 40 take math, and that 60 take English. So I'm going to look at my English bubble. So right now in English, I have 10 plus 25 plus 5. So that's a total of 40 people that are in my English bubble so far, but I need 60. So that means I have 20 people that are taking just English. In my math bubble right now, I have 30. But I know that 40 people are taking math, so that means I have to have 10 here. In my chemistry bubble, I have 35 people, but I know that I'm supposed to have 50. So that lets me fill that in with 15. So now I've got my Venn diagram full, and I'm just going to go through and see how many people are taking these classes, right? So I'm going to add up each of these numbers. 20 and 5 gives me 25, and another 25 gives me 50, 60, 70, 85 people total. But my problem tells me that 100 people total were surveyed, which means some people aren't taking any of these classes at all, right? 85 people are taking some combination of English, math, and chemistry, but the other 15 people are taking different classes or not taking these classes at all. So those 15 people are outside of the Venn diagram like that. Okay, my friends. And so that tells us what we need to know to have this Venn diagram correctly filled in. Now, what we need to do is figure out the area of this Venn diagram that corresponds to people taking at least 2 subjects. Right? So we're looking for a Venn diagram where people take at least 2 subjects. That's this portion of the Venn diagram, where we have any overlap at all. People are taking at least 2 subjects. And so we can add up the numbers there. We know we have 25 plus 10 plus 5. That gives us a total of 40 people who are taking at least 2 subjects. All right, friends, let's look at problem 4, which is another percentage. A friend has an 83% average before the final exam for a course. This score includes the final, which counts for 30% of the course grade. And you want to know what's the best grade that your friend can earn. Give your answer rounded to the nearest percent. So there is a video on Lumen of a problem like this in your homework. It's also in the textbook for this section. So if you don't like my explanation, you might like that one better, okay? So I have an 83% average, and then the final counts for 30% of the course grade. So what's the best grade that your friend can earn? Well, you have to look at our grade totals. So I know that my final grade is going to be the 30% from the final plus the 70% of everything else, right? Currently, I have an 83% average. So what that means is I have 83% of this figured out. And I want to know what the best grade I could earn is. So the best grade would be if I got an A. If I got all of this 30%, if I got 100% of that. So let's set that up. I currently have a 0.83% of this 70%. And I'm assuming that I will get 100% of this 30%. And I can punch that into my calculator. 0.83 times 0.7. And that gives me 0.58. And then add all of those beautiful 0.30, that percent. And it's a 0.881. So that's an 88%. It's the highest grade your friend can get in the course. Nice. So what's the minimum that we need on the final to make sure that we get a C, that we get a 75%? So again, our final grade, we're looking at our final grade as 30% of this final exam and 70% of everything else. So we know that we already have 83% of our 70%. And what we're looking for now is we know we need to find X times 0.3. What's the grade on our final exam that we need to get to earn 0.75? So the 0.83, we're just going to clean this up. 0.83 times 0.70 gives me 0.581 plus 0.3x is equal to 0.75. So I can do 0.75 minus 0.581. And I get 0.169. And I can divide that by 0.3. And I get an answer of x is 0.563 repeating, which tells us 56%. Not bad, right? I bet you guys could do that on the final. So your friend is in a good situation for the final. Okay? Problem 5 is the meatloaf problem. It's kind of related to some of the stuff we did in class. We spent some time on this problem in class, and this is from the problem solving section. So this example is in your problem solving homework, and it was also on your problem solving quiz. So you need to make 5 meatloaves for a party. The recipe calls for 1 3/4 cups of breadcrumbs. You know the store sells containers of breadcrumbs with 4 2/3 cups of breadcrumbs in each canister. So how many canisters do you need to buy? Give your answer as a whole number of canisters. Okay, so for we need to make 5 meatloaves. Every 1 meatloaf is 1 3/4 cups. So the total number of breadcrumbs I need is 5 times 1 3/4. I'm going to convert this to a mixed number. That's 5 times 7/4. That's 35/4 cups total that I need. In each canister, there are 4 2/3 cups. I'm going to convert that to a mixed number. That's 14/3 cups per canister. So what I want to know is if I take my 35/4 cups and I divide that by the 14/3 cups in each canister. You can use your calculator if you like. No problem there. You can use what you know about fractions to manipulate these fractions and do it. Either one is fine by me. I'm going to use my calculator today because I'm trying to do this video a little bit quickly so I can get it posted for you guys. So then you get a decimal value, 1.875. But you can't buy 0.875 of a canister of breadcrumbs at most grocery stores that I know of, right? So I want you guys to give your answer as a whole number of canisters. So that would be 2. All right, my friends. Now we're moving into the finance section, right? So we're going to be using the different formulas that we talked about in class. For each problem, I'm going to walk through how to know what formula to use, and how to plug in those numbers correctly into the formula, I'm going to leave the calculations for you to do, right? Because I want you to practice using a calculator, and I want you to feel confident about your answers. And if you are still struggling with this next week, I can show you some of these answers in class and these calculator questions, okay? So the first problem, problem 6, says you deposit $300 in an account earning 3% interest compounded annually. How much will you have in the account in 10 years? Compounded annually tells me this is a compound interest formula. We currently have two formulas that involve compound interest. One is for annuities, and one is just for compound interest. So for annuities, you make regular deposits. And for compound interest, you make one large lump sum deposit. This problem says it's $300 into an account one time. So that's one large lump sum deposit. That means that the formula I'm looking for is my compound interest. This is the one we did in class most often, but it's okay if you use any of the other ones that work in the textbook, okay? So that is the formula we are going to use here. Let's go ahead and go through and fill in some numbers. So because I am compounding annually, that means my K is going to be equal to 1. Annually means something that happens one time per year. $300 is the deposit that I make, my initial deposit PO. 3% interest is my interest rate. Now remember, when you're putting this in, you put it in as a decimal. So what you put in there is going to be 0.03. And then they want to know how much we're going to have in the account in 10 years. So that makes N equal to 10. So if I'm filling this in, I know that Pn is equal to 300 times 1 plus 0.03 divided by 1 raised to the 10 times 1. So if you punch that into your calculator, you should get the correct answer. Okay? I want you to check and double check and work on your calculator stuff. Like I said, if you guys are still worried about it next week, I can show you. Okay? For problem 7, how much would you need to deposit in an account now in order to have $6,000 in the account in 15 years? Assume the account earns 6% interest compounded monthly. So once again, I see the phrase compound. And so because it says compounded, that means I'm looking for compound interest. We have two formulas involving compound interest. One for lump sums, one-time deposits, and one for small regular deposits. So this question says I need to deposit some amount of money into an account now in order to have $6,000. So that now lets me know, that word now is what is telling me that this is a lump sum deposit. So this is actually going to be the same formula as the first example. There is going to be a small difference in this problem. We will talk about it when we get there. Again, we have compounded monthly. So that is going to tell us our K. Our K in this situation is going to be 12 because we have 12 months in a year. So if it compounds monthly, K is going to be equal to 12. We also have 15 years. That's the time we're looking at. So that's going to be N. We have an interest rate here of 6%. That's going to be our R. And we have something different. We want to know how much we're going to need to deposit so that we can have $6,000 in 15 years. So this is our PN. 6,000 is our PN. So what we're actually going to be asked to solve for here is PO. That's the number that should be your answer. How much are we going to deposit to get here? So let me plug some stuff in for you. So PN we know is going to be 6,000. That's the amount we want to end up with. PO, we're not sure, that's what we're looking for. 1 plus 0.06 divided by 12 raised to the 15 times 12 power. So what you would need to do for this problem is you would need to get this number in your calculator and divide both sides by this number. So your final answer should be 6,000 divided by that number in the red box over there. Again, I'm not going to do the calculator work for you because I want you to practice it and I want you to be confident. If we are still worried about it next week, I'll show you. Okay? All right, so here let's take a look at problem 8. Again, we're going to figure out what formula to use and how to plug it in. So this problem says, if you wish to save up $120,000 using an annuity, what monthly payment is required into the annuity if the annuity has an APR of 10% compounded monthly and you wish to reach your savings goal in 20 years? Okay, so we have a really nice clue here using an annuity, right? So that means we're going to use the formula for annuities. So annuities say PN is equal to D times 1 I blanked out on the annuity formula. Oh, guys, this is why I give you a formula sheet. I'm going to check. I'm getting it confused with the loans formula, so I want to double check. Ugh, I'm so embarrassed. Ah, c'est la vie. These things happen. I'm going to go to our Lumen class page and make sure I use the same annuity formula you guys use, because there's a couple on the web. Deep sigh. Oh, I have your formula sheet right here. I'm sorry, my friends. This is truly terrible. There we go. Okay. I was right. I started to doubt myself. So our deposit is 1 plus R over K to the NK minus 1, all divided by R over K. This is why I give you guys formula sheets, because I know that blank out feeling when you just get anxious. All right. So let's talk about what we are going to plug in where into this formula now that we've got it here. So we want to save up $120,000. That's our target savings amount. That's the amount we want to end up with. That's our PN. And we want to know what monthly payment is required, right? So what monthly payment are we going to need to make? That's our D. So that's going to be what we're looking for in the problem. The annuity has an APR of 10%. So that's our interest rate. It's compounded monthly, which means our K is going to be equal to 12. And we want to reach our savings goal in 20 years. I already used yellow. Apologies. In 20 years. So that's N. So what you're going to want to do for this problem is you're going to want to find this number using your calculator. Once you have found that number, I'll highlight it in a nice little pink. Once you've found this number, here, you're going to take your PN and you're going to divide by that number. And that's going to tell you what your monthly deposit is. Okay. Let's talk about this traditional investment account, this IRA. It's a special type of retirement account in which the money you invest is exempt from income taxes until you withdraw from it. Suppose you deposit $100 each month into an IRA that earns 6% interest for 25 years. So we are going to be using the annuity formula here, and I'll tell you how I know. I see that I'm depositing $100 each month, which means it's a regular deposit amount, which means we're working with an annuity. So we're going to use that same annuity formula that freaked me out before. Is equal to D times 1 plus R over K to the NK, subtract 1, all divided by R over K. This one I am going to work out for you guys because this one seemed to cause some trouble. So I want to make sure you guys see how this is going to go. So let's go through and plug in what we have. So my deposit is $100 each month. My interest rate is 6%. So I'm going to have 1 plus 0.06 divided by K. When does it compound? I don't see anything in the problem that tells me how often it compounds, which means it compounds as often as I make my deposit, which is monthly. And so we're going to do this for 25 years. 25 times 12 here in the exponent, subtract 1, and we're going to divide that all by 0.06 over 12. So I'm going to punch that into my calculator for you so I can give you guys a final answer. So I have 100 times 1 plus 0.06 divided by 12 raised to the 25 times 12, and then subtract 1, enter, using my answer key to take that and to divide by 0.06 divided by 12. And so for this, we would end up with $69,299.40. Okay. So that's the total amount we're going to earn with this annuity. How much will you have deposited in this account over 25 years? So we make a $100 deposit every month for 25 years. So 100 times 12 will tell us how much money we deposit in 1 year. That number times 25 will tell us how much we deposit in 25 years. So we have 100 times 12 times 25. So we have actually deposited $30,000 of our cash over this time. If we want to know how much interest we've earned over the 25 years, we can take the money that we have. This is what we end up with. And we can subtract the amount we deposited And that number is going to give us the amount of interest that we earned over time. We only put in $30,000. I say that like it's a small number. We put in a lot. So your total amount of interest that you earned was $39,299.40. So the answer for C and D is actually the same number. You may or may not remember that the formula for actual change says you take your end quantity and you subtract your starting quantity. So in our problem, our ending quantity is the amount that we earned over this 25-year time period. And our starting quantity is how much money we put in. So the actual change in your investment, the money that you've earned, right, via interest, is good. Your investment went up. You earned money. Yay. I asked you D, even though it has the same answer as C, because I was trying to set you guys up for part E. The relative change is a formula that we talked about in class. So that relative change says you take your actual change and you divide it by your starting quantity. And so I wanted you guys to realize that your actual change was the amount you've earned over 25 years. So I added in part D to help you realize what number you should use in this situation. So we end up with $39,299.40 divided by our starting amount, $30,000. And so this answer should be as a percent. So I'm going to divide in my calculator. And as a percent, this is 130%. Or 131% if you round correctly. I would have accepted 130, 131%. The point of this question is I would like you guys to see just how big of a change of a percentage increase these kind of regular deposits have. Right, so this is a way of putting together information that we've learned throughout the semester to understand something about investments and how, $100 every month is a wise thing that you can do if that fits into your budget. Problem 10 was fun for me. I really liked seeing the different things you guys talked about. It's a great way for me to reward you guys for the hard work that you did studying, because I know I didn't put everything on the test that you might have been excited to see. Problem 11, I'm going to give you guys some tips that I think we can work on. So tip number 1 is homework. Most of these problems are straight from the homework. Some of them even have videos and how to solve them embedded in the homework. If you do them, see them, take notes on them, that's going to help you. Tip number 2, office hours. I really would like to see you guys come by. I have office hours right before our class on Tuesdays and Thursdays. So I'm always there for the hour right before class in my office. It's in Tech 153. And I would love to talk to you. I'm just there waiting to tutor students, basically. So if this video didn't make sense, didn't help, if you need more from the class, I really would like to invite you personally just to come by and talk with me. All right, my friends. I hope this video was helpful. I hope you're having a good and restful week, and I will see you on Tuesday.